the trick is, or the important thing for the compiler and for this type here to work is that you could specialize this thing. And when the compiler first passes the code, it doesn't know whether you're going to specialize it or not. So it cannot assume that the value is actually false, and therefore the static assert doesn't fire. It only fires when you really instantiate it, because then the type is known, and then the compiler knows, okay, there is no specialization for this, and the value is indeed false, and then the static assert fires. And this thing here is a template alias, so we're covering lots of stuff from C++11 today, is a template alias, and template aliases can't be specialized. So this thing here is always of the false type, and if you use this, and shamefully I have to admit I tried that too because it's much shorter than that. But if you use this, then you're in the same situation as with the original false. Yeah?
Or you could make it shorter by deriving wrong type from false type,
Yeah.
instead of repeating the content of false type.
True. But, well, yeah, I'm using inheritance in this library all over, but I'm not a big fan of it. It's just because I have not found another way to do all this type and name magic. Okay, so in the end it's going to look like this. So you have the specification, and then you just use it like this. Okay. So very nice and gives you very, very short error messages. Okay.
A quick remark.
Hmm?
The size of trick actually works because kind of the same reason here.
Mm-hmm.
Because to evaluate the size of, he has to know t beforehand.
Yeah.
But it's guaranteed that the size will never be 0. So if you do the static check size of t equals 0, it will basically do the same thing.
Yeah.
You don't need the template alias, which you might not have.
That's true. The good thing about this work, though, is that the whole static assert line is printed out to the user. And it's much clearer to the user that, okay, I'm doing something wrong here. Wrong, and this is why. And the size thing, of course, it works, but
You have to know
a little bit more about template programming. And users of this library are not required to know everything about template programming, of course.
Why not?
It would be useless. It doesn't hurt, but it's not a requirement. Okay. So, next thing is partial specialization of functions. By the way, how are you in the time?
I think we're about 1 hour in.
Okay, with a bunch of questions, so okay.
So that's just 1 more.
It's not too long. So, partial specialization of functions. Well, if you know your templates, you know that there is no partial specializations of functions. There is no such thing. But what if you wanted to have one? Because sometimes it would be really handy. Like in serialization, as I said in the beginning, the expressions that we write in SQL++11 are vendor neutral. So the connector library has to translate that into something which is vendor specific. And this is done, for instance, in a serialization step, where you can translate an expression into a string, which is then used in the library for the database. And the default implementation is, well, we serialize concatenation in this case, string concatenation, and the default way is to use the concat operator. But for instance, in MySQL, there's the concat method, because unless you use a specific configuration flag, it doesn't even understand this one. It doesn't. So, in case you're using MySQL and you're serializing from MySQL, you want to do something different. You don't want to use this. So, and based on the context, which contains information about the database, you want to have a different function here. Okay. And at first glance, it looks like, okay, we can just specialize for the context, but this is a member function of a struct that has a left-hand side and right-hand side operand. So in total, we have 3 arguments here, 3 template arguments, and if we just want to specialize for the context, because that's all that interests us, we have a partial specialization for this member function. And there is no such thing. So, okay, that's just the short version. Options are overloading, for instance. You could have specific functions for the MySQL context. But then the library wouldn't be vendor neutral anymore, because it would have to know the MySQL context class, and well, since there are hundreds of databases, there could be hundreds of these classes, and we don't want to know all these in the vendor neutral library. So that doesn't make sense. It makes sense in other areas, but not for this library. We could use flags in the type, so the context could contain some information, some static information, whether to use the concat operator or the concat function. But turns out that at the moment I know at least 3 versions of what could happen here, and I can think of many more. So it doesn't really. That's unwieldy. So I tried that in the beginning and said, okay, I implement connectors for these 3 databases, and okay, we have just two versions, and then I can use flags to differentiate. But there are potentially hundreds of ways to serialize or interpret this concat object. So in this context, again, it's not really an option. The third variant, and there are probably some more, is to dispatch to a static method of a template struct. And the template and structs can be partially specialized, and I'm going to show you how this is going to work. So this is, and that's what we're using here in this library. So instead of having a meaningful body here, we just dispatch to a serializer template, which takes the context argument and the concat struct as template arguments, and just hands over the context object and the concat object, and lets this thing do whatever it's required to do. Okay. Yes, and now this, as I said, this doesn't have any meaningful content anymore. So we can, since we have to have serialized functions for all members of the template tree, we can just move it out of the class and have a free function. And this is what the whole thing would look like in the beginning. Now we have a serialized function that takes a t, so for instance the concat object, that takes the context object, which is then a vendor-specific context, so for instance for Postgres or for MySQL, and it just forwards the whole stuff to this template here, which has to be specialized for all the possible T's that you'd have, and that might have a default implementation, so for any context. But if you're writing a connector library which wants to have a specific implementation, then you can have a specialization for this context type as well. Okay, and if something is not implemented yet, which especially during development happens quite often, then we're using this wrong thing again and say, okay, this serializer specialization has not been implemented yet, which is a very nice error message. And if you compare it to what the compiler gulps onto the screen, if you don't have something like this, this is a huge improvement. Okay, so how does it look like? So if you have a MySQL context, and we're trying to serialize a concat object with a left and right argument, then this is a partial specialization of this serializer object, or serializer template, and basically this is the function. So it gets the concat object in the context, and in these examples the context have a streaming interface, so you just stream in concat, opening bracket, then serialize the left hand side operand, comma, right hand side operand, closing bracket, and you're done. Okay. Questions about that? Okay. Now we get into Franz, I think, asked that in the very beginning. What else could you do with these expression trees that we generate here? And I called it serializer all the time in the previous slides. That's for historical reasons I did that. Until a few weeks ago I realized that in reality we should call this interpreter, because we could not only serialize the objects in this tree, we could also interpret them in a different way. Okay, so just let's go to the next slide. So this is a bit of a guessing game. Yeah. So this is a interpreter class, so which is called by the interpret function or serialize function, whatever you want, and it's specialized for a certain container and an assignment. So we've seen assignments before. And what does it do? So this is the function. It certainly doesn't serialize anything, because, well, should contain something like equals or so. Instead, it returns an object, and what it does return is it returns an assignment. Well, not the same assignment as we entered into the function. That would be useless, I guess. It returns a different kind of assignment, an assignment from another namespace. And maybe we can ignore this for the moment. It returns an assignment of an interpretation of the left-hand side operand and an interpretation of the right-hand side operand. So what this does is it reinterprets the expression tree into something into something different. And the assignment type that it uses here is very similar to what we have seen before as an assignment. Again, it has members on left-hand side and right-hand side, and also has an operator where you could put in some object. And then the object is used with the left-hand side and right-hand side. So not only the assignment has call operators, but also the operands have call operators, and you assign the result of this call with the result of that one. So what we're doing is we're turning the compile time SQL expression into an expression of functors which now actually do something. I mean, the SQL expression is there, and you cannot use it otherwise as interpreting it. This thing here is a functor, so we turn the SQL expression into a functor. Okay? Okay? And once I realized that you could do something like that, it took less than a day to write a partial SQL interface to std vector. So what you could do now is use SQL expressions on vectors. You're laughing. Okay, so what does it look like? Well, you have similar stuff than you would have with any normal database. So you have include files which contain table definitions. You have the SQL syntax. You have the connector library which connects to a database. In this case, it connects to containers. Then this is the only time, by the way, that we're using some kind of namespace alias or something like that. But all the other examples were without using namespace, whatever. This is just for shortness reasons here. And then we have a struct, a sample struct, which is quite ordinary. And the sample struct corresponds to the table definition that we have in our header here. And then we can just, as normal, create or define that container is now a vector of sample, create some instance of this vector. Now we have an empty vector of these sample structs. And we initialize a database with this, because that's our connection to a database for containers. Now we can just insert values into it, just like into any normal SQL database, with a typical SQL syntax. So you have a table dot column equals something. You can use all kinds of stuff there, and the insert is probably not really a thrill. But you can also use selects, and I think this is going to be more interesting. I think it's going to be really interesting that you could now use the SQL language to select values from containers, for instance. In this case, from a vector. And current implementation is really just for vector, but could be used for sets and maps. Could be used for streams and so on. And so, yeah, you have this select expression. Looks kind of exactly the same as in all the other examples before. Just in this case, it doesn't serialize into a string, which is then forwarded to a database, which then generates results, which have to be translated into all these types. It just returns, in this case, it returns a vector containing references to the complete database, and then you can iterate over it and have the results here. Yes?
Is it possible to join two vectors?
Not yet, and I haven't really spent any thought about on that. But I guess it will be. I don't know. So, I mean, this example is not extremely impressive, I think, but I have several applications in one particular software that I'm using at work, which is going to benefit from this and make code which is this long and it's to be crunched into maybe this. Because these expressions can express things in different ways than what you would normally do in the same amount of lines. Okay. So, what's next? After having shown that it can be used to access vectors or to use vectors as databases, I think sql11 has the potential not only to be used for SQL databases, which was the original use case, of course. I'm sure that it could also be used for ODBC databases, for NoSQL databases, probably not all kinds of cases, but there are several examples already out there where people write NoSQL databases and then see that the users are confused by it and then add artificially an SQL interface to those databases because users are, well, confused. This library makes it very easy because you get the syntax for free. All the parsing is for free. You can use it for containers. You could use it for streams. So incoming streams could be analyzed with SQL queries. You could use it for XML, for JSON, for CSV, I don't know. Right. So that's what I think that you could do. It's a very recent finding that this would be possible. Yes.
Do you think it could also be used for events?
Even stream?
Like you set up like queries on incoming events. When something happens, then go there.
Yeah.
Right.
I mean, then go there. I don't know. I mean,
Well, I guess it depends on the interpreter how you could define.
I mean, you could use the select statement to filter events. At
Yeah.
least.
You need triggers
Yeah.
for this.
Yeah.
The question about SQL databases, how do you make sure that your C++ model corresponds to the database scheme?
Oh.
Do
Okay.
you
Let's.
do you throw
That is-
exceptions or?
No. Can you go back a few slides for the MySQL specific? Okay, this one here. So let's say your database does not support concatenation of strings.
No. It's about let's say the
Table definition.
yeah. It's
Oh, okay. Sorry. Well, as with all software that interacts with databases, you have to make sure that the database and the software are in sync.
But the question is, what happens if they are not in sync?
The same as always happens. So you get undefined behavior in the end. Because you try to address columns that are not there or have a different meaning. So depending on what kind of differences there are, there will be different errors. So in general, you can't really say. But what you could do, it's not in place yet, but what you could do is based on the table definitions that you have in the software, check whether the database matches your software.
But let's say the connection is lost.
Mm-hmm.
What happens then?
The interaction with the database is not part of the library itself. So it's depending on the implementation of the connector.
Yeah, but the library should
It will
publish
it
some.
will propagate the any exception that the connector throws. And then, well, it's up to the connector. If the connector tries to reconnect or whatever it does, if it creates a log file, I don't know what.
So you are using the exceptions thing. Actually.
It would then use exceptions, yeah. Okay. Good. The other question that I thought you asked, but didn't, is just if your database does not support all features that are in the standard, then well you could just raise an assert here and just say, okay, this feature is not supported by this database, which makes migration much easier, because if you use some feature like, for instance, auto-join, and then you want to switch to SQLite, which doesn't support auto-join, as far as I know, then you could just say, okay, auto-join is not supported by SQLite. Please try to find a different solution. And I would say so at compile time, which is really important. So you don't run into problems during production, even if you forget to test it. Okay, that's basically it. There's a last slide with acknowledgements. So I say thank you to everybody who has ever taken interest in this library. In particular, and in chronological order of contact, there's the Metafeed GmbH, that was my previous employer, Picaro Financial, the current employer and host of this event, who's also using this library for all kinds of transactions in our systems, and benefit greatly from the simplicity with which you can now interact with databases, because you don't have to care about many kinds of errors. Our CTO once said that it's always almost too easy to interact with databases, because now people are bolder about writing complex queries, because they know that the compiler will take off all the shit. Thanks to the Boost community and the ISO standard committee for many discussions about the library. Meeting C++, of course, for inviting me for this talk. Battle for West North, I don't know if you know that, it's a fantasy game on Linux. They actually want to use this library for a Google Summer of Code project this year. And of course the audience today. Thank you. Yes, you had a question. It looked like you had a question.
Just
Chris,
I have two questions. I will ask you the same questions which John de Guzman asked me at my first BoostCon talk. Like this, you will be prepared for if one day you get to meet him.
okay.
The first one is if I have a very complex query with lots of joins and so on, something like 20 lines, how long will it take to compile and how much RAM will I use? That's the first question which he asked. It was a big, I gave big numbers, he was happy.
Okay, let's say all the compilation time is, of course, slower than strings. That's no big wonder.
It's okay, it's expected.
That's expected. All the examples in this talk, which are in individual files, can be compiled within, I think, 5 seconds.
A big one? Let's say it's a bit bigger.
Yeah, much bigger. So, not nearly as long as the same amount of spirit code would take.
Let's still go further.
He did Guzman.
So it will be under 30 seconds.
Sorry?
Under 30 seconds.
Yeah. No, it's not so much. And what the RAM, I honestly have no idea. I haven't measured it.
It's 30 seconds probably not that much.
So we haven't run into any problems yet, and our current compile host isn't the strongest one.
So this will brings me to the second question.
Yes.
So yeah, I gave a big number, but still it was not big enough for him.